So guys, you can see it is sending the data as per our programming. Let me show you the code. See that we are sending here an empty space, then temperature equals to, then whatever the temperature is calculated by the sensor, and then we show it on the screen wirelessly using the Bluetooth module. So you can see that it is following the same coding sequence. There is a space, then temperature equals to, then whatever the temperature, then C and an empty space, and the next value. So it is continuously sending the value. Now I will turn off the power. I am powering up the circuit from the PIC. See, the power is off. Now the value stopped coming. See, it is no longer coming and it says connection lost. Now I again connect it. Let's power up the PIC because HC-05 is being powered up by PIC, and I press this button over here to connect. Okay, it's connected. See, it was trying to connect, but I accidentally disconnected it. See, so guys, that's it. Hello guys, welcome to learning microcontrollers. In this video, I'm going to show you how you can make a wireless temperature measurement system using LM35 temperature sensor and a PIC16F877A microcontroller. Then we are going to send the output in Celsius onto a smartphone using a HC-05 Bluetooth module. So let's get started. So guys, this is our PIC16F877A microcontroller having 40 pins. It's a DIP version. And this is the HC-05 module I'm talking about. It's a Bluetooth module working at 2.4 GHz frequency. So let me show you how it's labeled at. If you hold it like this, when the button is at the bottom, then the bottommost pin is the enable pin. Then you have VCC, ground, TX, RX and the state pin. Now this enable pin is used to enter into either the data mode or the command mode. When it's high, it means you are in the command mode. Now you can change the password, baud rate, etc. I have a video on that. I will share the link of that video in the description. And the settings we are going to use right now is the one I had done in the video. In my previous video in setting up a Bluetooth module. I will share the link of that video in the description. If you want to go through that, you can go through that. So we will use those settings which we did in that video. So we are not going to use the default settings. So guys, here we have enable pin that is for entering into a mode. So in this application, we are not going to need it. Just leave it untouched or connected to the ground. Your module is in the normal working state. Whatever the settings you have done, now they are applied. So leave the enable pin as it is. Then we have VCC pin, ground pin, TX, RX and the state pin. Now to connect it with the PIC, you will need the UART port of the PIC, that is pin number 25 and 26, TX and RX. So let's connect it. So RX pin will go to the TX pin of the PIC, that is pin number 25 of the PIC, and the TX pin of the HC-05 will go to the RX pin of the PIC, that is pin number 26 of the PIC. Now guys, connect ground to the ground, VCC to the VCC. In this way, your module is connected to the PIC. As simple as that. Now guys, this is our LM35 DC temperature sensor, easily available in the market. Now if you hold it like this, then from where the writing on the sensor starts, that is from where you can see the LM35L. That pin is the 5V pin. Center one is the output pin, ADC output, and the rightmost is the ground pin like this. Now guys, let's connect it with the PIC. You will connect the ground pin directly with the ground pin of the PIC, that is the pin number 12. Then guys, you connect the VCC pin of your LM35 to the VCC pin of the PIC like this. Then for the ADC pin, you can use any available ADC pin of the PIC. I'm going to use the pin number A0 like this. In this way, our LM35 is connected and our Bluetooth module is connected. Now guys, let me introduce you to the hardware before we move on to the programming. So guys, this is our hardware here. As you can see, this is the LM35 temperature sensor, and this over here is a Bluetooth module, and this is a smartphone we are going to use here. Simple as that. So let's get to the programming. So guys, this is our MikroC for PIC. Let me zoom in so you guys can see better. As you can see that on the left topmost corner, the version of the MikroC for PIC is mentioned. It's 7.2.0. You can use the higher versions as well if available. Higher is always better. Click on File, New Project. And here you can see that it's New Project Wizard mentioned here. Click on Next. Write the name of the project. I write LM35 HC HC-05 PIC wireless sensor tutorial. So this is set the path where you want to store the files and select the microcontroller you are going to use. I'm going to use a PIC16F877A. Then guys, set the crystal. This is a crystal connected to the pin number 13 or 14 of your PIC. I have a 20 megahertz here, so I will write 20 here. Click on next and finish. Now guys, this window will pop up. Before you do anything else, first of all, save your work. To save your work, press Ctrl S like this. Now guys, first of all, we will need to initialize the ADC pins for the sensor. So go to the right in the MikroE libraries. Here you have this ADC. Click on, check it, expand it, double click on the ADC I90. And in the ADC I90, you have this command ADC initialize. You copy it and paste it below the void main and give some initialization delay. It's not necessary to give initialization delay, but I suggest you always give it in the one time loop. Oh, sorry, the caps is accidentally on. Let me rewrite it like this. Now guys, for the HC-05 module, we will need a UART port. So write UART in the search. Here you got this is UART module. Check mark this library and double click on the UART1 I90 command. And in the example here you have this command. Copy it, paste it. Now guys, here this is the syntax of the command. This will initialize the UART pin, that is pin number 25 and 26, and this is the baud rate. Whatever the baud rate you had set in the settings of your HC-05, you will write that baud rate over here. I had set 9600 and 9600 is also the default baud rate, so 9600 will do fine here. So I give some initialization delay as well. Now guys, we have our HC-05 initialized, we have our temperature sensor pins initialized. Now what we need is that we need to go to the forever loop. So I write while one, forever loop starts here, ends here. Now inside it, first of all, we will need to read the value from the sensor. For that, we will need a variable which will store the value coming from the sensor. So we take an integer variable int, I write it temp, temperature. And now to convert it into a Celsius, we will need another variable which will store it in Celsius, temperature C, that is in Celsius. Now guys, we cannot send this integer directly to the HC-05. We will need to convert it into a string. For that purpose, I go to the right. Here you go to the conversion library. There we go. This is the conversion library. And here you will need to use a command called integer to string. But let's first get the value from the sensor. So write down temp here equals to ADC underscore read from which channel? Channel 0. See that this is our variable which will store the value coming from the sensor. This is the command and this is the channel. Like I am using pin number A0, so I had written 0. If I was using A1, I was to write 1. That's all. Now guys, give some initialization delay to the command, 10 will do fine. Now guys, we have our sensor value coming. Now we need to convert this value into Celsius, which will be more suitable because we will need to convert the raw value into centigrade. For that, just use this variable tempC. Now what we do is that we write equal to whatever the value is in the temp, multiply it by 5. 5 is the reference voltage. That is like make it 5.0. It is like the voltage we got gave to the sensor, that is 5 volt from the PIC. If you are giving 3.3 volt to the PIC and the sensor, then you will write 3.3. Whatever the voltage you are giving to the sensor, you have to give that voltage here. This is the VREF divided by 10. That is the maximum resolution of LM35 module. So this is it. This will convert the raw value into the degree centigrade unit. Now if this equation don't work on your sensor, it gives some other values. This means that your sensor is not original, it's a copy. There are so many copies in the market. So you can check a sensor by using this simple formula. So this is it. Now we have our sensor value converted to centigrade. Now we will need to send this over the UART channel. For that we will need to convert it into a string because string is more immune to noise. It do not get distorted easily. So you go here, this is IntToStr command, double click on it. Now this command over here, you copy it. This will convert the integer into a string. You write it here. So this will be the integer which is needed to be converted. That is our temperature in degree centigrade. Now we will need to initialize a string, an array of char, which will store the converted value. So tempC1 and maximum characters it can hold, I make it like 6. Okay, that's fine. So this tempC1 is an array of char. An array of char is a string, so it can hold maximum of 7 letters. So I write here this variable, copy this variable and place it here. Now this command works in such a way that whatever the integer is, you write here. Whatever is in this integer will be converted into a string and will be stored in this variable. So that's all. Now we give some initialization delay again. Now we will need to send this value over the UART channel. For that we will need the UART command. So now you go to the UART library, write down UART, and here you have this UART write text. Double click on it. This window pops up. You copy this command UART write text output and you paste it here. Now again go back to the library. There you have this command UART1TX ideal. Now you copy it, copy the complete and go back, paste it here, delete these two here and now give the ending bracket here like this. Now guys, this command over here, if UART-TX ideal, this checks if the TX buffer is ideal, only then it will allow the data to be sent. This will save you a lot of effort. You don't have to like catch wrong values. It will only send a value when the TX buffer is ideal. Else there can be a ragged back value which will distort the data. And this over here you will write the thing which you have to send. We need to send this tempC. So whenever the TX buffer is ideal, it will send the temperature to the screen in centigrade. Now we also make it look some beautiful. So copy this here, else it will keep on sending data and we will not be able to read it. So we give some empty space here, like we will have empty space and then it will first of all send an empty space. Then what it is gonna do is that it will send the letter temperature, that it is sending temp equals to like this, and then after sending the temperature, then now it will send the temperature. It will be again give some empty spaces like this. Okay, one empty space, then we write Celsius. I think this is the spelling. Okay, it will send the temperature. Okay, we write centigrade. Only C will do fine. So what it's gonna do is that it will here take the sensor value from the sensor by this command, then it will perform convert it into a centigrade, and then guys it will convert this integer into a string. Then it will send the string over the UART channel by some making a bit look presentable. Now we build this code and see what happens. Okay, the code is built, no error. Now what we do is that we go to the PIC16 programmer tool, let it open up. Okay, it's opened. Okay, select the microcontroller. PIC16F877A is the one we are using, this. Then guys go to the file, import hex file. Here you have this file we just created. Now write. Okay, the new file is being written. Let's zoom out and get to the hardware. So this is our hardware. You can see that Bluetooth module is blinking. See, it's done. Now we power up the circuit using the PIC3. I click on. Okay, the circuit is powered up. You can see that HC-05 module is blinking right now because it's not connected. Once it's connected, its blinking will slow down. So what I do is that now I turn on my mobile phone. So there are a lot of apps you can use. You can use various apps. So first of all, what we do is that we go to the settings here. Okay, you can simply go to the Bluetooth like this. Go to the Bluetooth setting, turn on the Bluetooth of your phone like this. Now what you do is that see, this is here learning microcontrollers. That is the name of my HC-05. It's connected. It's already paired, so I don't have to enter the password. I connect. See, it's connected. Now there are various apps in the Play Store or on the Google APK files. You just write the HC-05 in the Play Store. Write HC-05 like this, and various apps pop up. Just download any. I download the top one. I'm using this. I click on open. Okay, it's opened. Okay, now go to these 3 lines here. Now here you have these devices. Click on the devices. Now here you have your device, learning microcontrollers. I click on it. See, it is trying to connect. Okay, see, you can see the temperature is coming. It is showing the temperature. See, whatever the temperature is, it is coming to the screen. I hold the sensor to increase the temperature. So guys, you can see that we are receiving our data in the same sequence as expected. See that our temperature sensor is here. See, this sensor is sending the value. The sensor might be broken, it's an old sensor. Let me remove the ADC pin of this sensor. You will see the values will change. I remove this wire over there, see. Now you can see the ADC pin is not connected, so it is sending random values. See that? It is sending just random values because I had just put off the ADC pin. LM35 is a very sensitive sensor, so it gets damaged easily. I think this sensor might got damaged. So let me reconnect the wire. So it is giving the temperature. This sensor is basically over the time loses calibration. You have to recalibrate it. That's fine. Rest is easy. So you can use any sensor to make such a system for sending the temperature and other values to your mobile phone using HC-05 module. So guys, now I will disconnect the module to see does this really work. See, it's disconnected. Okay, I disconnected. See, the values have stopped coming. HC-05 is disconnected now. See, it is giving an error. So this was the sensor sending the values. I again connect it. See, it's connected. Now I again press this button over there to establish the connection. See, it's connected. Again the value starts to come. So guys, this is how you can make any wireless sensor using this technique. So I hope you guys learned something from this video. If you have any question, you can ask in the comment. Thank you very much for your time and have a nice day. We'll see you in the next video.